Hey guys, it's Mr. DeFelice. Today we're going to look at symptoms. You probably learned this will be a review from Algebra 1, but I'm going to throw in some stuff today from Algebra 2 that will be new to you. Before we can start simplifying, there's a couple of key terms you have to go over. First, you have to remember what a coefficient is. So on my paper I already highlighted the coefficient of this expression. The coefficient here is 4. A coefficient is just a number that's in front of your variable. The variable is a letter that represents the value you would plug numbers into. So in this case, x is my variable. I can replace x with any number that I want to and then solve this expression. And the last one is the exponent. The exponent is the power that something is being raised to. So x is being raised to the second power, which means I'm multiplying it by itself 2 times. So very quickly we're just going to identify the different coefficients, variables, and exponents just to make sure we understand these. Because in order to combine like terms, you need to have a solid understanding of each of those definitions. So in this problem, my coefficient here is 8, my variable is c, and the exponent is 2. In this problem, my coefficient is -9, my variable is x, and here, when you do not see an exponent, it means that there's an exponent of 1, because anything raised to the first power is multiplying it times 1. Here, I don't see a coefficient, so the number we always say in front is 1 if there is no coefficient. So 1, the variable is y, and then 8 is the exponent. Why is 1 a coefficient? Well, if you multiply anything by 1, it stays the same, so nothing changes there if I keep the 1 there. In this problem, I have 12 as my coefficient, and I have 2 variables, a and b, and then my exponents are 2 and 3. So in order to combine like terms, you have to find terms that have identical variable parts, so the same letters, and the same exponents. So they have to have the same letters. This is just letters, or letter, and the same exponent. When simplifying, you use addition and subtraction. You combine like terms by keeping the like term and adding or subtracting the numerical coefficients. So you're just adding or subtracting the numbers, and the letters stay the same. So here's a couple examples. I have 3x's and then plus 4x's. So 3x plus 4x, the x stays the same. I'm just adding the coefficient. 3 plus 4 is 7. Over here, I have xy as my variable, and this guy has xy as a variable. Minus 9, which is 4 xy's. And the last one, x to the third y squared, x to the third y squared. These are the same variables and same exponents, so I'm able to subtract them. Otherwise, if they weren't the same, I wouldn't be able to do it. So 12 minus 5 is just 7. Because really, here's what's happening. If you've got 3 x's, I'm adding 3 x's plus 4 x's. So 1, 2, 3, 4, 5, 6, 7. That's where your answer of 7 x's comes from. Let's look at these problems. Can you simplify this? Can you add these two things together? Well, check your exponents. The exponents are the same, so that's good. But the variables are not, so this is no. They have different variables. So actually for that problem you would be done. That's as far as you can simplify. Here, in this problem, they each have the same variable, but there's different exponents. I can't subtract these then because they have to have the same exponent. So again, no. This time they have different exponents. And finally, in this one, again I see the same variables, xy, xy, but the third power is on x in this problem, and the third power is on y in this problem. So no, these guys are not the same. So you cannot simplify them. So let's try a couple practice problems. I'm going to simplify the following. If you think you can do these, go ahead and work on them and pause the video and then fast forward to see if you can get to the answers that I get as well. Alright, number 1. 7x plus 5 minus 3x. The like terms in this problem are the 7x minus the 3x. So 7x minus 3x is 4x, and I can't do anything with 5, so I'm done. There's my answer. Sometimes it's helpful to circle things that are like, and then that way you know which ones you're combining. Next problem, 6w squared plus 11w plus 8w squared minus 15w. So I've got a couple variables with different exponents. 6w squared goes with 8w squared. So if I do 6 plus 8, I get 14w squared. This w and this w are also the same, so I'm going to do 11, because it's positive 11, minus 15, which is negative 4w. And you're done. Generally, when you write your answers, you write it in highest exponent to lowest exponent. So this is the second, so it's higher than this exponent, so I started with that number. Number 3, look for the like terms. (6x) and negative 7x. So 6 take away 7 is negative 1x. These guys are like terms. 4 and 15 don't have any variables, so I can combine those to make 19. On the bottom, same process. 12x minus 7x is 5x, and negative 5 minus 11 is negative 16. Number 5, got a couple different variables. There's a lot going on in this problem. 2x squared and negative 3x squared. Notice the minus is in front of it, so it's 2 minus 3x squared, so it's negative x squared, because 2 take away 3 is negative 1. Here I've got negative 3x plus 4x, so negative 3 plus 4 is positive x, 1x. And then I've got 7 and negative 7. So 7 take away 7 is 0. I don't need to write the 0 because adding or subtracting from 0 doesn't change the problem. The last one, be very careful. Can I simplify this? This has an exponent of 2. This only has an exponent of 1 for the a. B has an exponent of 1. B has an exponent of 2. So this is as far as it goes. So you could just rewrite this answer to be simplified. You can't do anything with this problem. Okay. These should be review, hopefully, from what you've learned in algebra. The new skill that we're going to work on today deals with those irrational numbers that we were working on in the first couple weeks of school. So let's just review a couple terms. First one is a radical. So a radical is a radical sign, that square root sign, with a number inside of it. So it could be like the square root of 3 or the square root of 2. These are radical. You could say this is radical 3, radical 2. All radicals refer to square roots unless otherwise specified. A radical with a small number in front of it refers to a root other than a square root. So for example, if you see this 3 right there, this is called the cubed root. If I put a 4, that's called the 4th root, and then so on. And you have a 5th root and a 6th root, and so on. The numbers inside the radical sign is called the radicand. So this is called a radicand, the number on the inside. The radical sign acts as a grouping symbol. We talked about that when we did orders of operations. A radical is a real number. All radicals are irrational numbers except when the radicand is a perfect square. So we learned about that when we did real numbers. The square root of 16 is 4. So this one is not irrational. But the square root of 15, that's a number that we can't simplify into a nice whole number. If the radicand is a perfect square, the radical is equal to a rational whole number, which I just showed you with the square root of 16 equals 4. And a radical term is a term containing a radical. So we can do operations like adding and subtracting with radicals. So it says radicals can be added and subtracted as like terms if they are like radicals. A like radical is a radical of the same degree with the same radicand. So it's got the same number underneath the square root sign. And it also has the same root. So it could be the square root, 3rd root, 4th root, 5th root, so forth and so on. So there's a couple examples. 3 square root 5s, so I've got 3 square root 5s plus 1 square root 5, Altogether gives me 4 square root 5s. Notice, just like terms, the root 5 stayed the same. I just added the coefficients. If it helps, you can pretend these are like x's. And you've got 3x's plus 1x's, and that gives you 4x's. Same thing here. 4 root 5 minus 6 root 5 equals negative 2 root 5. So 4 minus 6 is negative 2 root 5. These terms can be added or subtracted because they are like radicals. They have the like radicand underneath the radical. In examples 3 and 4, if you take a look, I've got 3 root 5s plus 1 cubed root of 5. Notice these ones cannot be added because this is a different root than this one. They have to have the same number or no number there in order for you to be adding or subtracting them. That's true for the second problem. These terms cannot be added or subtracted because the roots are different. This is a square root and this is a cubed root. The last one, 3 root 5 plus 1 root 6, I can't add these together because they are not like terms underneath the radical. They're not both 5s. Pretend this is like an x, and this is a y. You wouldn't add those together because they're not like terms. Same thing here, you can't subtract these because they do not have the same value underneath the radical. So try the following 6 problems on your own. This will be your assignment for tonight. See if you can simplify those radicals. If you have any questions, just check it with Mr. DeFelice. I'll have a key.